Okay, so how cool is it that we can go from a pretty long method of graphing to a very short method of graphing? So remember, in math, we're always looking for patterns in order to make things more efficient and faster. And what we realize today is when we have the A equaling 1, our movement from point to point starting at the vertex is going to be a vertical movement of 1 and a horizontal movement of 1. Then the next point will be a 3 vertical movement and a 1 vertical movement. Then the next point would be a 5 vertical movement and a 1 vertical movement. If we have A equals 2, we take that parent graph, which was y equals x squared. That's what we kind of started out with. We take that parent graph and we multiply everything times 2, you see? And we have that same kind of movement, but now we do it by 2. And the same for 3. We take the parent graph, multiply it by 3, and we get our vertical, and our vertical. And notice that the horizontal movement is always 1 when we have a whole number like this. So the same thing goes when we have -1, -2, and -3 for our A's, except we already know that this is going to be reflected. So it's going to you're going to be going down vertically instead of up like we did in class. So I'm going to give you an example right here. Y equals -2x squared plus 4x plus 7. If I give you this example, the only math that I have to do is I have to get the vertex. So I get the vertex by -b over 2a, which means it's -4 over -2 times 2 equals -4 over -4, and that equals 1. So that's my x value. That's my 1. I find my y value by plugging in 1, so I have -2 times 1 squared plus 4 times 1 plus 7, and what does that come out to be? Well, it comes out to be -2 plus 4 plus 7, and that equals 9. So my vertex is 1, 9, and that's it. That's the only math I have to do. So what did I mean in the homework by choosing a smart graph? Well, if I'm going to be in 1, 9, I really only need quadrants 1 and 2. I don't really need these guys down here, so I don't have to make this a perfect T. So now I'm going to go and I'm going to graph this point, 1, 9. And there's my vertex. Okay? I also know that my line of symmetry is here. We talked about that. And I'm going to put my line of symmetry as a dotted line, because that's the coolest thing about parabolas, is that they're beautifully symmetrical at the vertex, x equals 1. And now I have to say, well, which way is this graph moving? Is it going to go up like this, using my pencil, or is it going to go down like this? So I have to say, well, A is -2. If A equals -2, that means I'm going to be going downward. And now I'm going to follow my movements. Well, I know from the vertex I go 2 over 1, then 6 over 1, and that's all I really have to do. But remember, when I go negative, I have to move down. So from the vertex, I go down 2 and to the side 1. Then I go down 6, 1, 2, 3, 4, 5, 6, and over 1. So this is going to be a really, and if I had enough room, I could go down 10 and over 1. But I don't think I have enough room. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just barely have enough room. You can't even see it on the paper. If I move it up, you can see it. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 1. Now the greatest thing, like I said, about parabolas is that everything is symmetrical. So this is over 2, so I go over 2 here. This is over 1, so I go over 1 here. And now I have this beautiful symmetrical shape. And I have to do my best to really make this look like a U. So I'm going to lift up my pencil as I make that U. Okay? And again, we know that it's not a perfectly straight line, it's a curve. So we just have to kind of do our best to be as artistic as we can. It ain't easy, but definitely doable if we just take a moment to do it. Oops, I didn't give my 1, 2, 3. There we go. Now I didn't have to keep going. I could have just stopped at these 5 points, which are fine. But just for fun, we did that. Okay? And there's my parabola. Now, what would happen if I gave you a different equation? Again, you have to identify your vertex. You have to identify your A, so you can decide, well, what kind of rapid graphing am I going to do? If the A is 1, I'm just going to move 1, 1, 3, 1, 5, 1, just like we did in class today. If the A was 3, I would move 3, 1, 9, 1, 15, 1. Now, most likely you're not going to be moving these guys. If you can, but you don't have to. And don't forget, if the A is negative, we have to be looking down. This is when A is negative 2. If A was positive 2, this would be looking up if it had the same vertex, which I would have to get a completely different equation for that. So, if you're thinking about doing this for homework, well, if you're thinking about doing this work, stop this video, try to graph this guy. So if I just cover up what I want you to graph, okay? So stop what you're doing, try to graph this guy, think about exactly what you know, this beautiful pattern, this fabulous pattern that we have, and then try to rapid graph from the vertex. You can always check with Desmos too.